Hello folks, this is a small demonstration of a simple simulation of how planets move in the space. The simplest one is to check out how it does the test. And the test setup is nothing else than a simple solar system, the Sun in the middle, Earth and the Moon orbiting around the Earth. All this is calculating by the differential equations of the attraction due to the gravity, and we can easily see how nicely the moon is orbiting around the earth that is orbiting around the sun. For some fun, I can switch on tracing, then the trajectories will be recorded, kept on the screen, so you can easily see how weird the trajectory of the moon is around the sun. While the Earth is kind of close to a circle moving around the Sun. Sure, we know it's an ellipse. Sure, we know it's not exactly an ellipse. Like a spirograph as the Moon is orbiting. Not exactly coming back to the starting position. And if you have a good eye, you can also see there is a trajectory also for the Sun. The Sun is also moving, which is okay. It is moving a lot compared to the Earth, which is okay because in the simulation the mass of the Sun is not that million billion times more than the Earth. We can switch off the tracing to see how things are going. We are still orbiting. Nice. Let's make an exercise. Artificially, I can decrease the speed of all the moving bodies, and what we expect if I decrease the speed, then the attraction will overcome the inertia, the impulse of the moving bodies, so the moon will crash into the earth and the earth will crash into the sun. But let's see. I decrease the speed. Maybe we can see that the moon is getting a bit closer to the earth, and we can also see that the earth is getting closer to the sun. That was a one-time loss for the speed. By one press, one portion of loss. As I remember, 10% is lost from the motion energy. Still orbiting, surviving. One more decrease of the speed. Yeah, it's very strange how the moon is moving compared to the Earth. Almost getting very far from the Earth. This would happen if to some reason this phenomenon happened in reality. Chasing the Earth, actually getting out of the orbit, out of the lock from the Earth, doing the orbiting on its own around the Sun. I mean the Moon. And let's see whether the Earth is catching again the Moon. Has some chance. Chance is gone. Or comes again. One can probably solve all these equations and calculate by math what should happen, when should happen. That's the beauty of simulation. You don't have to do the math. Of course, the accuracy of the simulation matters a lot. This is for demonstration, so not much effort has been done for error reduction, conservation of momentum or angular momentum, things like that. Okay, let's be brutal. Decrease still further the speed. And now we're getting closer to the sun. I make a repositioning so that it's at the middle of the observation window. And to some extent, I believe we can also see that the trajectories are by principle elliptical on a one-on-one situation. This is three bodies, so not exactly elliptical. The moon was almost caught by the Earth. Decrease again. I could also increase the speed, but then they would just get farther from the sun. And after a certain while, would forever escape from the sun's gravity. Yeah, never the gravity, so never zero. Oh, and now the moon got so close to the Earth that it was almost forced to orbit. Or still, not now. Imagine how funny it was sitting on that Earth and watching the moon. Okay, still decreasing the speed twice. We can see that the moon is almost up at the farther part of the ellipse. And I think we are getting close to the end of the universe, the end of this solar system. Ah, but not that fast. But it's getting hot, being so close to the sun. We can see how the speeds decreases a much when the orbiting body is far from the center of gravity, in this case from the sun. And when it gets close, it speeds up. Now I have almost stopped them. By the way, the motion energy is indicated there. It is changing, of course, because some potential energy is also accumulated and lost. And the final stop, if I switch on friction. We never have friction in the space unless I switch it on in my artificial world. And that was the end of the game. Friction means that they continuously lose energy. And having so little energy, they couldn't withstand the killing gravity of the sun. What we can still do to see what happens if we have several planets with a random initial speed. I have set it here 11 planets. Let's start the simulation by the restart. I zoom out to see what happens. Sometimes we are lucky and we can see that solar systems are formed, but that's not easy to generate. You need some luck to see that. Yeah, we have, and when planets collide, then they merge. So that's why you get less and less planets in the simulation. I restarted hoping for more luck. Here we can see some orbiting started. Yeah, yeah, two planets collided and merged. Oh, that was a big scale merge. Yeah, problem is friction is still on. You can see that's why they are crashing. I switch off friction and restart it without friction. That will be different. Yeah, less crashes. But yeah, yeah, that was one. What will happen here? Let's check. Whoops. Zoom out a bit to see better. And what happens here? That's start of an orbiting maybe. Here. I think they seem to be logged. If it is too slow, it will crash into the other one. If it is not that slow, it starts orbiting. Yeah. Switch on tracing to see how this orbiting looks like. Yeah, maybe not much to see. But we see the orbiting is happening here in a way. Oh, this is very beautiful. Let's watch them further. Here we are, here we go. I position them to the top left corner and switch on tracing to see how nice it will be. Yeah, trajectories cross each other. And the third one is just moving out of the rectangle, but these two ones are still close enough to each other so that they can be considered as orbiting one around the other. Yep. Let's see once more the crossing. Yeah, who is farther is pulled to accelerate. Who is in the front is is braked to retard. And now they swap the position. So this is really an orbiting. Here we go, these two ones. Yeah, if I zoom out, everything seems to be slower, obviously. But let's see when it is zoomed out. Finally, all the planets are moving downwards to the right, but these two in the middle are coupled around each other. This is how nicely they travel with the group. I have no clue about the masses. They are also random, so around a certain value. So we cannot say that all of them have the same mass. And they can come close to each other. So something interesting may also happen here. Wow, that should be anyhow the end of the game, that they get close to each other because they all attract each other. But it doesn't mean that you immediately will get a crash. That's not here either. Yeah, yet again. Let's see still a bit what will happen. They are quite close to each other. Wow. I wonder if it was a crash. And when he ran a surprising direction. Apparently there have been a crash. Out of the 4 planets, now we only have 2. Zooming out, stopping the trace. These are the 2 ones. Actually, we have also some others, but far away. So the impact is little or very slow, and we don't want to wait so much. So that's how you can play around with this simulation of the galaxies, and if you are lucky, you can see solar systems forming. Of course, the one planet, one sun setup is much more probable, but if you are really lucky, you can get to a 2 planet, one sun setup as well. You can also find here description about the usage. Give it a try. Goodbye.